All right, so the next topic I'm going to talk about is the greatest common factor of monomials. So monomials are a product of variables or certain numbers together, as we have 12y to the third and 15y squared. And what we do to find the greatest common factor of these guys is we first, step one, need to find the greatest common factor of the coefficients. And remember, the coefficients are the numbers at the head of the monomial. Step two, if the variables have, or if the monomials have variables in common, then we're going to use the lower power. So let's use this one for an example. The greatest common factor of the coefficients, 12 and 15, that's going to be 3. Okay, so 3 is the biggest number that divides 12 and 15. Step 2, if there are variables in common, so what that means, are there x's, are there y's, are there z's, are there a's in both? In this case, yes, there are y's in both. If that's true, use the lower power. So which one has the lower power, the cubed or the squared? Well, y to the second. So always just use the lower one, because you can at least take out that many in both. You can divide out that many. Let's go through a few more. So we have 3p to the fourth and 4p. So out of 3 and 4, what is the biggest number that can divide both of those? Well, it's just 1. Then I have p to the fourth and p. So there are p's in common. So I circle them both. Imagine that's a p to the 1. Okay, so which is the lower power? Well, the p to the 1. So I'm just going to put a p. You don't need that p to the 1. You don't really even need that 1 there at all either. So just a p. That's all you can divide out of that. 21m to the third and 28m. So out of the coefficients, I can divide 7 out of both of them. And then I have a variable in common. I have m to the third and m. So use the lower power. So that'll be the m. So 7m. 13x and 26. What can I divide out of 13 and 26? 13 can divide both of those. Now this one, I actually don't have variables in common. One has an x, one does not. So I can't include a variable here, because it's kind of like you're saying they at least have that many x's. So if I would have put an x here, that's saying that, well, off of this one and this one has to at least have an x, and so does this one, but that one does not. So that's what we leave off there. Going back to the previous examples, it's saying 7's the biggest number that divides it, and they at least have 1m. Okay, 28m has at least 1m. And up here, only one can divide the numbers in front, and p is the lowest, how many variables we have in each binomial. Okay, so moving on, just a few more problems. I have 2 and 4, so 2 is the biggest number that divides both of them. And these ones, they have 2 variables. So this one has x's in common, x to the second, x to the third, the lower power. So we're going to use x to the second. They have y's in common. So y and y to the second use the lower power. So 2x squared y. Out of 30 and 36, we can divide both of those. That should be a 6. And then I have s's in common. So use the lower one, s to the third. I have t's in common. So t to the fourth is the lower one. Continuing on, and these ones have a negative. Now, the negative is just kind of throwing you off. You don't really even need to worry about the negative. So 8 and 12. Ignore the negative. It's just trying to throw you off. 4, because 4 can still divide negative 12. Okay, so I have x squared and x to the third. X to the second is the lower one. And then the y's, just a single y is the lower one. So 16 and negative 8. Well, 8 divides 16 and 8, so let's write down an 8. I have x to the third and x squared. The lower one is the squared, so we'll write that down. I have y to the fourth and nothing. So I cannot include a y. They have to be common in both. That's why they call it the greatest common factor, because they have that in common.